Hi, my name is Alusan Barry. Welcome to this lesson on differentiation of implicit functions. In this lesson, we are going to solve a third example, this one, of how to apply the idea of differentiating implicit functions. Okay, remember earlier we defined implicit functions. Of course, all these functions you are seeing here, these are all implicit functions. Okay, it just means that in these sort of functions, it is impossible for us to isolate one of the variables, okay, one of the variables on one side of the equation. For example, if we want to isolate y on one side, then it's going to be impossible because x and y are joined up together, okay. And but for this second example, note that p is assumed as a constant. Okay, this example we are going to solve, p is assumed as a constant, so you treat it just as you treat 2. So you actually just treat them as 2p as one number. Okay, let's go on and get some space. Okay, now ourselves some more space. So let's go on and pick up a pen. Good. So the question we have here is, if x squared plus y squared is equal to 2pxy, where p is a constant, which means we treat it just as we treat 2. Find dy dx. Okay, so let's have our solution. And then, because it's a problem, of course, we want a solution. So what we'll do, as earlier, our steps for differentiating implicit functions, we say step 1, differentiate term by term. Okay, we differentiate one term and then we move on to the other term and then we move on to the other term. Okay, so let's move on here. If we differentiate x squared, we are going to have 2x. So it implies 2x, okay, because we are going to subtract 1 from it, so it just remain x raised to the power 1, and x raised to the power 1 is just x. And then for y squared, we are going to have 2y dy dx. Okay, I don't want to explain further, but we are just multiplying by the expression, subtract 1, but then we multiply by dy dx. That's how we deal with y's. Okay, so now the other side of the equation, we're having 2p xy. So we are going to treat 2p as a constant, okay, because p is also a constant. So now we are holding y and then we differentiate x. But differentiating x here is just going to give us 1. So just multiplying it by 1 will just give us 1. So let's just leave it like that. Plus, remember, this is the product rule we are using here. If you are having problems, go back and see the videos on the product rule. For y now, the next thing we do, we are going to, of course, we have 2p, and then we are now holding x constant and then differentiating y. If we differentiate y, we are going to have dy dx. Okay, so now we go on and say step 2, make dy dx the subject of the equation. Okay, okay, so if we make dy dx the subject of the equation, now we have already the 2y dy dx here, and then we have 2px dy dx. Okay, so let us have So let us transpose this to the other side and bring 2x to the other side of the equation. Okay, so we have, so this implies 2y dy dx, and then when plus 2px dy dx comes over, the sign changes to minus, to negative. Okay, negative 2px, because what we are literally doing is we are subtracting 2px dy dx from both sides. If we subtract this, so this and the negative one will cancel out, but we'll have the negative one also on the other side. Okay, so this is why we are just saying minus. Okay, 2px dy dx is equal to, we already have 2py here, 2py, and then when plus 2x comes over, it changes to negative 2x. But again, what we are doing is we are subtracting 2x from both sides. So this one we cancel out, but we have the negative one on the other side. Okay, so now organizing what we are going to have, let's factorize. We take dy dx out, so dy dx, if we take it out, here will remain 2y minus, here will remain 2px. Okay, this will be equal to 2py minus 2x. Okay, so now, but what we can do, we can divide, because what we were finding is dy dx, so we can divide both sides by 2y minus 2px. Okay, 2y minus 2px. So this will cancel out. So let me just have a bit more space. Okay, so we say hence this, like therefore, hence, so. Okay, hence dy dx is equal to, because we've cancelled this out, now we have 2py minus 2x all over 2y minus 2px. Okay, so this, my friend, is our derivative by differentiating implicitly, right? Yes, Mary, that's what we got. Good.